Very, not much.
Was it? Okay, Crewton Ramone's House of Math. Problem solving with all my students just for the heck of it. I'm on a little problem solving kick here since I'm building some problem solving pages, and because this kid is math enrichment, why not do some problem solving just for fun, right? So what have we done so far? We did some multiplication, we did some addition. We decided whether numbers were prime, composite, or square, and we got all the way to like 37. And he built some add-ins, and we basically had a fun time. Okay, so now he says that yes, he's seen these in school, but he has no idea how to solve them. So here's what I'm going to say. Let's make this so ridiculously easy it's painful. Okay, watch. And you're going to see, see, that's what I mean. The way they taught you in school, I guarantee you, was not this easy. And the way he was trying to show me just now, by more or less guessing and checking, was hurting my feelings. So, I'm going to end your misery and show you how easy this stuff actually is. Eventually you're actually going to like coming there. Because I know right now you don't. It's like if you could be playing video games or outside at the beach or whatever, you'd much rather be there. You don't even fool me. Alright, so I'm going to get 9. I need more green ones. Too many there. Alright, so what do I have? 3, 6. Ah, you know what? Screw it. There. 9. Okay. So, give me an equal sign right there. Because again, alright, fine.
Sorry.
Try and make them equal. Can you?
Yes, I can.
Oh yeah, but okay, fine. I was gonna say here, just draw 2 lines over here. Oh, look at him, he's getting all fancy now. Close enough. Punk, punk. All right, now we got equal sign. Okay, and what does that equal sign mean? It means
same.
Same. It means this is same as that, right?
Yep.
Equal sign never lies. We were just talking about that too, right? Okay, do you see stuff that's same on both sides? You see some same here and some same there? You see some same here and some same here?
Yeah.
Alright, take the stuff away that's same.
Okay, 2 of these.
No, sure. Put them down here.
Here, 2 of these.
Alright, fine. Alright, so we got same and same, right?
4
okay.
of these.
We got 4 here.
Yep.
Well, I don't see 4 from over here.
4 there.
Okay, now we got, okay, see now we got same taken away, even we can see it, we can measure. And we can see that we had
5 and
right?
5 and
so
10.
X
Plus.
equals, where do you see a plus?
Equals
X equals
not 5.
5. Let's check it. Was that easy?
Much easier.
Yeah. What's 3 times 5?
3 times 5 equals 15.
Plus 4.
19.
What's 2 times 5?
10.
Plus 5. Or excuse me, plus 9.
19.
19 equals 19 all the time, doesn't it?
Yes.
Every day and twice on Sundays even. Okay, so, and we can say, look, we've discovered now that each one of those x's was tricking you. It turns out that each x was only 5. Right? And there I have 3, right? 3 of them. Now that we know what they are, 3 of them and a 4. And then over here I have, how many?
You have 2.
2 of them. And 9. See that?
Yeah. Much easier.
Much easier. Now can we see, and we can even line them up, and we can see that the equal sign says we have 19. And over here I have 19. You see it?
Yep. Same.
They're same. See that? And that's see again. That's where the equal sign comes from. Right? Look, we've lined them up and they are same. They're exactly the same. So now we look at this and we see 3x plus 4 is the same as 2x plus 9 when x is 5. Right? And all we did was take away stuff that was same. Right? No guessing, no checking, just take away the stuff that's same. So when I take away stuff that's same, I do this. Watch. Hero 0! Hero 0! I took away 2x. I took away 2x. You can even see them right there. They're there. The 2x you took away. And then what I do, or actually what you do, you took away what?
I took away the 4.
And I took away the
4.
and that left me with 5. And the x equals 5. 0, hero 0, yay! Hero 0, yay! Right? 1x. Pretty simple, right?
Yep. The equal sign lies.
The equal sign never does lie, does it? It always tells you x is the same as 5. That makes this true.
Unless you mess up.
Unless you mess up, exactly. Oh, and then we could take it to the next step, was that 19 was the same thing as 19. And I could tell you a story about if we were making, say, pies, and one guy had 4 pies, and the other guy had 9 pies, and then they started baking for 2 hours, and at the end, this guy baked for 2 hours, and this guy baked for 3 hours. They bake the same amount of pies per hour, right? Okay, because they both have the same size ovens, and they make the same amount of pies each time. If this guy starts with 4, and this guy starts with 9, and they want to have the same amount of pies when they're done, he bakes for 2 hours, he bakes for 3 hours, and they have to bake how many pies per hour? 5, right? And at the end of it, they're done, and they make 19 pies each. Right?
Much simple.
Yeah. Okay, so anyway, story problem. Anyway, just make it all simple and easy to see what the heck's going on. And of course, with the blocks, it makes it that much easier to know what's happening. Right? Okay, so can you set the next one up? We're going to make one, and you're going to do it. I'm going to give you a problem, and then you got to put the blocks. Okay? All right, let's do that. All right. We can clean it up in the class. All right, so here is 5x plus 3 equals 4x plus 7, and he's setting it up.
I need.
What else do you need? So you got your 5x.
Then here you go, equal. Put an equal.
Oh, you want an equal sign? Okay, cool.
There you go.
All right, got the equal sign. Nice tiny equal sign.
And then we need 3x.
3 units.
3 units. And 7. I can make 4 and 3.
Why don't you use the 3? Oh, look at you getting smart.
What, 2?
Yeah.
3.
Oh, look at that. See, he's already starting to make some shortcuts for himself, because we know we're going to have some same stuff, right?
Yep.
All right. Bust it out.
Okay, so now, 4x. So we gotta take away the 2 4s. Leave the
4x, right?
Both of the 4x's.
Right. Lovely. And then what?
Then we take away 3 units from each.
And x equals
4.
How easy is that?
Very.
So let's stick this one in.
20.
Plus 3 is?
23.
And then what do you think over here?
And then 4x, so 4 times 4 is 16.
And?
Plus 7 equals 16, so then 23.
There you go. So 23 equals 23. We know we got it right?
Yep.
Okay. And we know that x is the same thing as 4.
Yep.
Alright. So you have written it down in your book.
Yep.
Now you need to put some symbols and draw a little picture. And here, I'll draw some pickers? I'll draw some pictures for you.
5x.
Watch. 1, 2, 3, 4, 5. 1, 2, 3. 1, 2, 3, 4. 1, 2, 3, 4, 5, 6, 7.
So you
Oops, 7.
So it'd be like this. It would be like 5x equal.
Wait a minute. What did we take away first?
We took away the.
First thing you did was take away the 4x, right?
Yeah.
So I'm going to take away that. I'm going to circle that and that. 0, 0. And then I'm going to circle this because you took away 3.
Yeah.
And I'm going to take away 3 over there.
Yeah.
And I'm just going to count what's left. I have 1x is the same thing as 4.
Oh, so you just put that.
There you go, right? Now, if I'm going to use symbols, these symbols, instead of these drawings, then I need to do some erasing.
Okay, is that really quick?
Right, yeah, get rid of that. And I'm going to do this. 0, 0! Minus 3. Minus 3. And then what did you do? You took away
4.
Minus 4. You didn't just take away 4, you took away 4x, right?
Yeah.
And you took away 4x. And then when I do that, 0, 0! 0, 0! And then that's just 4. And then that's just an x.
Oh.
How easy is that?
So then I took away 4.
Okay, so there he is.
And then took away 3.
Recording it. Now, does this make sense?
Yes, much more.
Yeah,
much more easier than what they taught us in school.
Yeah, there you go.
Then 4. And took away.
Okay, so anyway, write it down. I was going to make some comments, but I decided not to. When they taught you this, you were in California, though, right?
Nope. Well, yeah. They taught me California and also Princess.
And also here in Hawaii.
Yeah.
On Maui.
Awesome.
In
Two
Lahaina.
different places.
Yeah. And both times it didn't really make much sense.
No, I don't. I stay asking the teacher, and they keep telling me the same thing.
Yeah, well, see, that's the thing. They explain it over and over again using these symbols, and it doesn't make sense. But when you can see with the blocks, what you're doing, it totally makes sense. Because see, you won't, and we talked about this, we won't make the same mistakes. We won't make this mistake. Where say, I have 3x, right? And have you ever had, if I have something like, I'm going to write it this way, 3x, can I just take away 2 from 3x and wind up with an x? Or wind up with a 1x?
Yeah.
Can I do that?
Yeah.
Really?
Well, no.
Could I?
Yeah, you
just
could.
Take away 2? Could I, in other words, can I pull 2 out of this? Those 3x, can I just take away 2?
No.
Are those same? Is 3x and 2
no.
Same kind?
No.
Not at all, huh?
X's.
Gotta be x's. So now if I took away 3x from 2, now I can get 1x, right?
Yeah.
You see that?
Mm-hmm.
Does that make sense?
Mm.
Right? So you'll see kids try to do this. They'll try to take away the 3 from the 4 over here. Let's turn this around. Can I take away that 3 from that 4? I can't. They're not same kind. This is some units and these are some x.
Yep.
Right? And they'll get all kind of confusing, crazy answers. You wouldn't have to have been one of those kids, would you?
Maybe.
Alright, let's try another one. You're doing great. Okay, so he's put it in his notebook to write it down. Alright, this is the problem. And I've even drawn a little picture here. Here we have the moon base, and here is Spaceman Spiff in his rocket ship that goes 4 miles a minute, and he's 2 miles out of town, or out of the spaceport. Over here we have Spaceman Biff in his, but he only has 2 rockets, so he only goes 2 miles a minute, and he is 8 miles out of town. And we can see it, 1, 2, 3, 4. So now we got to figure out, when does this guy catch this guy?
Okay. How
far out of town are they? And if I was you, I'd do one thing. I'd put 2 green ones over here instead of having
2 green ones?
in it. Yeah, because you gotta find stuff at the same. It'll be easier. You know what I'm saying?
Greens.
Don't use greens. You could use that, and then you could do that, just like you did a second ago.
Yeah.
Okay, right? So do I still have the same?
Yeah.
But now it's just easy to see the green guys is all I'm saying.
Much easier.
Right? Okay. So, in our story, Spaceman Spiff sets out and tries to catch Spaceman Biff. So first thing he does, boom, take away that, excellent. Okay, then what? Take away that, right? See, now see how easy it is to see him? And like if you're a little kid, you could really see, right? Okay, so 6, but I have 2x. So what does 1x equal?
1x equals 3.
How'd you know that?
Because you cut this in half. You cut it in half and then...
Doing 1-to-1 correspondent, great. Here's another way to look at it. See, that's 2? Yeah. Now I could have 6 over here like this, right?
Yeah.
But if I had 6 over here like this, these rectangles wouldn't be the same. This rectangle would only have 1 here, and this rectangle would have 2 there. Yeah. So I'm going to make this rectangle the same by reshaping it like that. Right? So now I see this is 2, that's 2. That's 3, that's x. X must be the same thing as 3. Does that make sense?
Oh.
Totally. It's the same thing, right?
I was thinking...
well, but I mean, it's the same thing you were doing. I'm just showing you an algorithm or the math behind it.
So it's still 6, right?
So it's still just 3. So now...